Hi everyone. In this lesson we are going to look at a combination of a resistor and a capacitor in the same AC circuit. They're connected in series, and we're going to be looking at what happens to the voltages across the capacitor and the resistor and how do they compare with the supply voltage. So if you have, here's a resistor and there's a capacitor, and we're looking at the voltages across a resistor and a capacitor in a series circuit where you have your supply voltage, and the supply voltage is given as Vs. Okay, now let's say the voltage across the resistor is 8 volts and the voltage across your capacitor is 6 volts. So you would imagine or expect the supply voltage to be the sum of these two voltages. So 8 plus 6, you'll think it's 14 volts. But if you actually have a voltmeter across the supply voltage, you don't see 14 volts, but you'll only see 10 volts. And you think, how come that's happening? So the reason why this happens is that the voltage across the capacitor and the voltage across the resistor are out of step. They don't peak at the same time. They don't become zero at the same time. In fact, the voltage across the resistor is 90 degrees ahead of the voltage across the capacitor. And how do you know this? If you have what's called a dual trace oscilloscope, which is a gadget where you can connect this and you get a trace of voltage against time. If you get two sets of traces at the same time, you see that they're out of step. And the way that this can be represented is by drawing a voltage against time graph. So on the same set of axes, you can have a graph for the voltage across the resistor. So the blue is the resistor, and then in that time you'll see that when the voltage across the resistor is 0, the voltage across the capacitor is a maximum but 90 degrees behind, and every time the voltage, so this is what happens when that's 0, that's a maximum. And when that's maximum, there's 0. So this is what you get. So the voltage across the capacitor is also a sine curve, but it peaks at a different time. So this is the voltage across the capacitor. Now, one way of doing this, an easier way of doing this, is by drawing a phasor diagram. So I'll just draw my reference circle, something like this. Now, it's customary to draw the voltage across the resistor, my blue line over here. So that's my voltage across the resistor. My voltage across the capacitor is 90 degrees out of phase, so that's just here. This is my voltage across the capacitor, and if you add them vectorially, you'll get the voltage across the supply. So how do you add them vectorially? So one way to add this is by using what's called the parallelogram of vector addition. So what you do is you complete, these are two arms of the parallelogram, if you can say two sides, and you complete it. So you get that line is parallel to the red and this dotted line is parallel to that, and your supply voltage is the diagonal. So that's your supply voltage. So if VR is 8 and VC is 6, looking at that triangle, it's a right angle triangle. You can use Pythagoras, and your VS squared is actually equal to VR squared plus VC squared, or VS is equal to square root. VR squared was 8 squared and VC squared is 6 squared. So 8 squared is 64 and 6 squared is 36. When you add them both, you get 100, and square root of 100 is 10 volts. So that's how you get it. So yes, you do add them, but you have to add them taking directions into account. So when you add them vectorially, you get this. And the other thing that's useful to know is what is, VR actually, because phasors go around anti-clockwise, we say VR leads VS or VS lags VR, and we can say that VS leads VC. Now to get the phase difference that's expressed as an angle, the phase difference between the supply voltage and the resistor voltage, you just have to find this angle theta, which would be in this case tan inverse of 6 divided by 8. So I don't think I have my calculator just next to me, but I'll just show you. So your theta is tan inverse of 6, so that's 6, okay, same as that, divided by 8. Make sure your calculator is in the degree mode and you're going to get some sort of angle, and you say whatever that angle is, you say VS lags VR by so many degrees. So that's how you do those questions. And so once you've understood this, what you're meant to do is probably read through this page. This is what I've just explained, and then there are some questions on voltage and phase in capacitor resistor circuit. So there are 3 questions, and if you can work your way through those. Okay, so bye for now.